Okay, so I learned last night that the homework video again didn't record sound, and so I need to check the sound every time I start a recording here. I wonder if it'll keep recording if I check the sound while I'm in here. Yeah, looks like it's still recording, so yeah, it's set correctly. When this is set to auto and it defaults to that, it stops recording the sound, so. Okay, so we're doing 2.7, pages 41 and 42. The first one they've done for us, which is kind of nice here. And in this one, we're when they say interpret the remainder, what we're doing really is converting it into a fraction. And so you take the remainder and you put that on top, and that's the numerator. And circle that in green here. And that goes over the divisor, which is what you divided by. Okay? And so we'll do that on each one of the problems. But we can practice a couple here in reducing fractions. And let me see here. I'll just make up I'll make up a problem here. If there was a remainder of 9 and the divisor, or what you were dividing by, was 12, and I'll pull a stick here. Let's see here. Miss Bowman, can I reduce that? I want to change that into a fraction or a reduced fraction. Yeah, actually I can. Mr. Buckman, can you see what I can do with that? Can I reduce that? I want to think of a number that will go into both of those. 6 won't fit in the 9 evenly. What's another number? 3, yeah. 3 goes into 9 how many times? 3 goes into 12 how many times? 4. So it reduces to 3/4. Okay? How about if I had a remainder? I'm just going to write it down this way. A remainder of 12, and the divisor, which is what we divided by, of 24. Okay, what would that become? Miss Dart, what would that fraction look like? What goes on top? What goes on the bottom?
12 goes on top.
Yeah, 12's on the top. What goes on the bottom? Yeah, 24. Good. Now, can I reduce this fraction?
Yes.
To what?
3.
Well, not 3. It's still going to remain a fraction. Mr. Duhamel.
You can put 12 fits into both of those.
Yeah, 12 fits into both of those. So 12 goes into 12
One time.
and goes into 24
Oh, 2 times.
2 times. So 12 over 24 becomes 1/2. All right. How about if I had a remainder of 10? Did that. And a divisor of 15. Okay. Mr. Wooldridge, what would that become?
5 can go into 10.
So I'll put it as 10 over 15, and you said 5 can go into 10,
2 times.
and 5 goes into 15,
3 times.
so that becomes 2/3. What if I had a remainder of, 20? And what I was dividing by was 80. Miss Nealons, what fraction would that become? How would I originally write it? Just do the initial fraction. What would I write it as? So back to this. The divisor goes on the bottom, and the remainder goes on top. Remainder is 20, divisor is 80. How would I write that fraction? Say again? Okay, what goes on the top? 20, okay. So you guys got to learn how to do this. So now my next question is, can I reduce this? Is there a number that will go into both of those? Well, think about 10. Does 10 fit into 20 evenly? Sure, 10, 20. Is there a remainder? Yeah, okay. How many times does 10 fit into 20? Twice. How many times does 10 fit into 80? 8 times. Okay. Now we have 2 8s, but we're not done. Is there a number that will fit into 2 evenly and a number that will fit into 8 evenly? 2, yeah. How many times does 2 fit into 2? How many times does 2 fit into 8? How many? 4, good. So that reduces to 1/4. Okay? You guys got to learn how to do this. I'm going to do 2 more. What if I had a remainder of, I'm going to say 7, and a divisor of, making fun of my 7, and a divisor of 21. Miss Reyes, how would I set that up? Thank you. It's pretty easy. Now, is there a number that will both go into 7 and 21?
3?
Well, 3 doesn't fit into 7 evenly. 7, yeah, 7 will. So 7 goes into 7 how many times?
Once.
7 goes into 21 how many times?
3 times.
Okay, nicely done. Mr. McWilliams, I had a remainder of 8, okay, and a divisor of 64. What would the initial fraction be? The first fraction that we're going to work with, what would it be?
8/64.
Thank you, 8/64. Now you need to think of a number that will go into 8 and go into 64.
8?
Yeah, 8 goes into 8 how many times? 8 goes into 64 how many times?
7?
Close, 8. So that reduces down to 1/8. Okay? Miss Nealons, I'm going to pick on you once more. Let's say I had a divisor of 16 and a remainder of 4. What's my initial fraction? What's my initial fraction? What's my first fraction that I start working with? Okay. It's going to be 4/16. Okay, can I reduce that to what? What number will go into 4 and what number will go into 16? 4 goes into 4 how many times? 4 goes into 16 how many times? Yep, reduces down to 1/4. Okay. All right. So let's look at number 2 here. What is that, Marcia?
Garcia. Marcia.
Well, we're going to say it's Mr. Paulson.
No, it's Mrs. Paulson.
Okay, shh. Mr. Paulson has 412 bouquets of flowers. Wow, that's very sweet.
It's for himself.
4 centerpieces. Okay, shh. She uses, I'm sorry, he uses 8 flowers for each centerpiece. How many centerpieces can he make? Okay. Mr. Clifton, set that up for me. 400 and what?
I mean, 412 divided by 8.
Okay, good. 8 goes into 4, it doesn't. 8 goes into 41, how many times?
7? Oh, what? 26. No. 5.
5. What's 8 times 5?
40.
So subtract 40, 1 left over. Then what?
Oh, bring in the 2.
Okay. 8 go into 12.
Yeah.
How many times?
1.
What's left over?
4. 5. 4.
Okay. So it's 51, remainder 4. Now, you have to remember what goes on top, because we're not going to leave it as remainder 4 here. We're going to change it into a fraction. It's going to be 51 and something. So the remainder's 4. Here's I'll write it over here. What goes on top?
The 8.
Nope. The 8, I'll use this. The 8 goes on the bottom. And the remainder goes on top. You guys might want to color code this yourselves if you need to. Okay. So what does 4 over 8 reduce down to? What number will go into 4 and what number will go into 8? What's that? 4 goes into 4 how many times? 4 goes into 8 how many times? So it's 51 and 1/2. Okay? All right, let's look at number 4. No, not number 4. Let's look at number 6. Now, not all of these will have a remainder, but I think most of them will. Well, let's see here. Trying to figure out the best way to view this here. Can you guys see my... Yeah, I think so. There we go. All right, so number 6. Let's see here. Mr. Paulson. All right, Jenny has 220 ounces of cleaning solution that she wants to divide equally among 12 large containers. How much cleaning solution should she put in each container? So what do I do here?
Do 12 divided by 200. Wait, yeah, 220.
220 divided by what?
12.
Okay. And 12 doesn't go into 2. Does it go into 22?
Yeah.
How many times?
Once.
What's left over?
10.
Yeah. Now what?
Bring the 0 down.
How many times does 12 go into 100?
No. 8 times?
Yeah, 12 times 8. Let's see here. Let's go over here. Let's do 12 times 8. Okay. 8 times 2 is?
Oh,
16, put down the 6, carry the 1. 8 times 1 is 8, plus 1 is 9. That's 96. Yeah, nicely done. So it's going to be 18 times, and it's 96. What's left over? What's the remainder? Yeah, 4. So the remainder is 4. So now my question is, I'm going to write a fraction here with the remainder and the divisor. What goes on top?
4.
Yeah, the remainder goes on top. And it's 4. And the divisor, where does that go?
On the bottom.
It's going to go on the bottom, and that's 12. So there's my fraction. 4 over 12. Can that be reduced? Is there a number that will go into 4 and go into 12 evenly?
Yeah.
Yeah, what's that?
4 can go into 4 ones.
Yep.
And 4 can go into 12 3
1/3. So it's 18 and 1/3. 18 and 1/3 what? Ounces. I think I might have forgotten that in the last one. So don't forget to put ounces. Going back to number 2, it should be, yeah, centerpieces. Okay. Questions on any of these so far? No? All right. Yeah, we'll figure that in a moment here. So I want you guys to work on these. I'll do a couple in a homework video to help you out. And let me stop this here.